Maps. They are attempts at representing our countries and continents on a flat surface. To follow the Wikipedia definition, in cartography, a map projection is a way to flatten a globe's surface into a plane in order to make a map. But there's an issue. It's impossible to do it in a way that is 100% accurate, because we need to transform latitude and longitude lines from the globe into locations on a plane surface. A lot of times people use an orange peel to explain this issue. If you peel an orange, you can't flatten it out on a table without messing the peel up. And so all projections of a sphere on a plane necessarily distort the surface in some way and to some extent in order for all of it to be present. This is why we have a lot, and when I say a lot, I mean a lot of map projections. Just searching for this video, I found around 250, and they are virtually infinite, because depending on the purpose of the map, some distortions are acceptable and others are not. Therefore, different map projections exist and are created in order to preserve some properties of the sphere-like body that is the Earth, at the expense of others being distorted. They can belong to 7 groups, but I'm going to try to not get too technical here, especially because I have very little idea about the technicalities and mostly go at it from a visual perspective. The most well-known map projection used in the majority of maps across the world is the Mercator projection, presented by Flemish geographer and cartographer Gerardus Mercator in 1569. It's pretty old, and its generalized use has to do with the date in which it was invented. These were the times of the European colonialism and maritime discoveries, and so this map focused on representing any constant course of constant bearing of a ship as a straight segment on the map. To put it simply, if in order to get from southern France to Canada, your ship had to just go forward and never turn, then the map would show a straight line between the two locations. And so this projection became the standard map for navigation. However, it has a big issue. The Mercator projection inflates the sizes of objects away from the equator. This inflation is very small near the equator, allowing countries and continents there to be represented very accurately, but becomes distorted, being too big as it moves towards the poles. In this GIF, yes, GIF, not GIF, we can see countries being reduced to their true size. The ones near the equator have little to no change, while the ones up north shrink a lot. Greenland appears to be the size of Africa, when in reality it is 14 times smaller. Madagascar looks the same size as the UK, when in fact it is twice its size. Alaska seems to be the same size as Brazil, when Brazil is 5 times bigger. Antarctica looks gigantic, when in reality it is reasonably small. It's just at the southern pole, and so is reachable on a globe from all surrounding areas depicted here on the southern part of the map. And so, in order to depict that reachability, the map must show it distorted like this. I made a video about this specific issue once regarding the true size of countries. Eventually, the Mercator projection has become a little less used, although I think it's still the one in the majority of maps, but a lot of them switched to better ones, which are more accurate. A good example, and one extremely used nowadays, is the Robinson projection, developed in 1987 and adopted by the US's National Geographic Society in 1988 as their official projection. Before that, they used the Van der Grinten projection, which reduced Mercator's distortion in the center by concentrating all of it in the poles, which were extremely distorted, representing the globe as a circle. The Robinson projection almost solves it entirely though, and is honestly my favorite one because of this. The distortion in size is basically non-existent, and only the actual poles are distorted, like we see with Antarctica, but something which I think is justified with the necessity of showing its accessibility from all areas of the south-southern hemisphere. An interesting aspect in the majority of these projections is that the distortion is usually horizontally symmetric from the equator line. I'm sure there's some mathematic reason behind that. The Berman projection from 1910, for instance, shows a really weird looking Central America, South America, and Africa. They are way too disproportionately big when compared to North America, Europe, and most of Asia, but they are disproportionate in a symmetrical way. So now we've understood three things. One, all maps are distorted because it's impossible to depict a globe on a flat surface. Two, the type of distortion the map has depends on what it was made for. The Mercator projection was made for ship traveling, and so it prioritizes that, the courses and directions, sacrificing object proportions in some parts of the map. And three, other maps have since tried to correct those errors in distortion, either prioritizing other aspects or attempting to depict our continents in the most accurate way possible on a flat surface. This is why there are so many projections. Before we go on with the video, a quick message about today's sponsor, ExpressVPN. Whenever we are online, we're divulging information. Either we are aware of it by, for instance, sending someone a message, or we're not, and websites we visit retrieve it from us without us knowing they do, like information about you, your IP address or location. Plus, your internet service provider knows everything you do as well. ExpressVPN puts a stop to all of that by encrypting your data and hiding your location. This way, hackers, websites, and service providers can't access your data and use it for negative things. Plus, you also get the added benefit of being able to visit websites that are geo-restricted. I recently wanted to watch The Office on Netflix, but that isn't available where I live, and using ExpressVPN allowed me to switch my region to the US, accessing their catalog and watching the show. Find out how you can get 3 months free by clicking the link in the description box below, expressvpn.com/generalknowledge. All these maps we've seen so far have been, however, pretty standard and straightforward, in the sense that they are the way we expect a map to look like. But what about all the other projections that look way different? Let's start with this one. This is the transverse Mercator. Essentially, it stems from the Mercator projection, but depicts it in a different shape/angle. Now, again, I'm totally ignorant regarding the math behind this, but it's in the math that the difference is, and that's something out of my area of expertise. But there is the obvious difference in the visual aspect. Here, the pole sizes are pretty much near perfection, but other areas suffer as a consequence. Southeast Asia is way too big, as is South America, but Antarctica is perfectly depicted. So if we were to use the two Mercator projections side by side, we would have an almost perfect depiction of our world. We also have examples of maps which didn't have to deal with Antarctica's problem because, well, when they were made, Antarctica hadn't been discovered yet. Lambert's conformal conic projection from 1772 is a good example of this, and it's actually extremely proportionate in pretty much every aspect, although it is missing the tips of South America, South Africa, Australia, and New Zealand entirely. This map projection is apparently still the basis for a lot of the aeronautical charts used by air pilots, because a straight line drawn on a Lambert conformal conic projection approximates a great circle route between 2 points for flight distances. What we therefore understand is that essentially when cartographers and geographers develop these map projections, they always come up with specific mathematical principles behind them, and these principles can still be used today even if the original map projection itself is not, because it became outdated. That's why the amount of map projections is virtually infinite, because we can always change something in a projections equation, even if a tiny detail, or come up with an entirely new projection. Another example of a perhaps outdated projection is the stereographic projection. All of these have really complicated and technical names that I don't understand either, so the best way to understand them is by seeing how they look. This one is also known as a planisphere projection, and it dates back to antiquity, having been used in some of ancient Greece and Rome's maps. Depicted on a circle, instead of being centered on the equator, it is centered on the North Pole, with an increased level of distortion as you move away from it. But the errors were excusable, because the point was to depict the northern hemisphere with a high level of accuracy. However, some more recent projections just wanted to depict all continents with a minimal error possible. An example of that is the Airy minimum error projection, which pretty much took the globe, cut it in half, and put two circles side by side. Some follow the same trend and use two different surfaces put together, like Van Leeuwen's GC, which uses two triangles, or Adam's hemispheres, which uses two losangs. This circle one is very accurate, but still not perfect, because it's not possible to demonstrate the curvature of the globe in the central part of the circle. And so these areas here, Russia, the Central Asia Istans or India, are a little too far stretched when compared with Italy or Ireland over there. We could stay here for hours just looking at map projections, but I think at this point we've understood the basic principles behind them and why they are so different and vary so much. Like a projection proposed by Leonardo da Vinci in 1508, which set the path for Cahill's butterfly projection by attempting to divide the globe into 8 pieces. So I'm just going to show you 2 or 3 more that I found really cool looking and that are amongst the most unique out of the currently existing models. First, the one I just mentioned, which comes from Leonardo da Vinci's ideas, the Cahill conformal butterfly. In it, we see the world depicted in 8 triangles. And honestly, it might not be in the orientation we're used to or in a rectangular depiction, but I kind of love it. Look at the accurateness of the sizes, the precise depiction of Antarctica's reachability without having to stretch it to no end. It's just totally brilliant. Plus, the issue we have of certain continents being split can be solved by moving the triangles according to our desire. These are visible in other forms of arranging this projection, like the Cahill conformal M-shaped. There's also the Cahill-Keyes projection, which depicts the world also in 8 triangular shapes, although one of them has an additional piece for Antarctica. There is also a cool one called the Cheslonge conformal. The name, I guess, comes from the fact that it looks like one. It's pretty good, and despite not looking like it because it's separated, it shows us the entire world very accurately. However, I feel the way of dividing it isn't the best because it takes away our notion of distance, and if we didn't have pre-existing knowledge of where things are in relation to each other, it would be kind of useless in terms of serving its purpose as a map. Then the Dymaxion-like conformal from 1943, which attempts to transform the sphere into an icosahedron, a shape with 20 sides, then flattening out those 20 sides on a surface. It preserves shapes and sizes very well, but is heavily interrupted as a consequence. But to be fair, I think at this point, the goal of the makers wasn't to create a useful map in the sense of it being good for navigating via sea, land, or air. They were, or are, just trying to make the most accurate depiction of a globe on a flat surface. And finally, the Tscherning 1 from 1982, which I just find extraordinary because it really takes the whole stretched Antarctica thing to a max. It depicts the world in a semicircle, being centered on the top center in the North Pole and having the southern pole stretched all around its limits. So that is a quick overview of map projections, why they exist, why they are all necessarily inaccurate, how some of them prioritize depicting some aspects correctly and others not, depending on what they were made for, and how some of them have attempted to be the most accurate possible. There's literally hundreds of other projections, but I couldn't fit them all into a video with an acceptable length, so if you're interested in this, just Google it and you'll find endless information on it. Thanks so much for watching this video, subscribe if you want to, and leave a comment below with your favorite map projection. I will see you next time for more general knowledge.